हूँ। Very good morning, Mr. Gaon.
Good morning, good morning. You can hear me well?
Yeah, we are able to hear you well. Thanks a lot for joining.
It's fine.
Yeah. We will start the session in another 6 minutes from now.
Yeah.
So it is exactly at 2 Indian time.
Yeah.
Oh, thank you. You are absolutely fine.
Yeah, fine.
Thank you. Very good afternoon, sir. Sir, you are on mute. Very good afternoon.
Sorry, I was muted. Good afternoon.
Thank you, sir. Thanks a lot for joining.
Am I audible fully?
Very clear, sir. Very clear.
Okay.
In another 5 minutes exactly, we will start, sir.
No problem, sir. No problem.
Okay. People are joining.
Yeah.
We have right now close to about 46 people.
46. Okay.
46. Sure.
Good afternoon, Gurmeet Saab. You are muted, sir.
I'm sorry. Good afternoon, Giri. How are you?
Very fine, sir. Thank you. All well. Thank you.
So, Mr. Bjorn has joined or no?
Yeah, he has joined, sir. He has joined. We will request him to, put his video on and mic on.
Bjorn, good afternoon.
Good afternoon. Good afternoon.
It
Or
is
good
now
morning
2:30,
from here.
2 o'clock in India, 2 p.m.
Yes, it's only 10:30 here,
Yeah,
so we're
that's
3.5 hours.
That's right.
Following you in everything. Also,
Well,
Mr.
you're the
Bjorn.
Bjorn, you're the third most famous person I've met with the same name, Bjorn.
oh,
Bjorn Ulves from ABBA,
yeah.
okay, right? And
Yeah.
and the tennis player,
Björn Borge, yes.
Thornborg.
Yeah. Well, they are both Swedes, and I'm Finnish, even if I'm living in Norway. But it is a Swedish name, very much in use for boys, yes.
Right.
And it's translated. It's a bear, the animal. So
Oh, the deer. Okay.
no, the bear, the
Bear. Okay, the bear.
bear, yes.
But three famous people, huh? With the same
Oh,
name.
thank you.
Ah.
Thank you.
So, Karthikeyan, let us know when to start. We have a lot of registrations.
Another 1 minute to go.
1 minute. Okay. Okay. We'll wait for a minute.
I think we are audible to everybody, right?
Yeah, very clearly we are audible, sir. Yes.
Yeah.
I think, Giri, we can start. Yes.
Thank you. Good afternoon, everybody. It's my pleasure and privilege to welcome you. Good morning to Bjorn Erik, who is joining us from Europe. Mr. Gurmeet Singh Arora, Chairman of IGBC, Bjorn Erik, Chairman of Global Ecolabelling Network, and all the participants of this seminar on low carbon building products and materials. This is a joint initiative of GreenPro India and Global Ecolabelling Network. This is a sort of a capacity building exercise, awareness building session in terms of low carbon building products and materials. As we all know, India is committed to be a net zero country by 2070. And of course, IGBC has launched the mission on net zero. More than 300 organizations have committed to be part of this initiative. As buildings work towards net zero, becoming net zero, it's extremely important to have low carbon products and materials which go into the construction of these buildings, which ultimately become net zero. There's a need for low carbon products and materials for reducing both the operational impact as well as the embodied carbon. And GreenPro Eco Label, which is recognized Type 1 Eco Label of Global Ecolabelling Network, enables architects, engineers, developers to choose the green and low carbon products for construction of their buildings and built environment. More than 5,500 products have till now been GreenPro certified. The program therefore focuses on low carbon products for buildings and built environment. We are extremely privileged to have Mr. Bjorn Erik. Bjorn Erik is the chairman of the Global Ecolabelling Network, a network which comprises of 29 eco-labeling organizations representing 60 countries. And as a type 1 eco-label has progressed significantly in the last 30 to 40 years. And one of the important leaders who have been responsible for the growth of type 1 eco-label has been Bjorn Erik. He has been involved in the eco-labeling movement right from the very beginning, and he's the general manager of Nordic Eco-Labeling and a well-known expert in eco-labeling. Name any international conference where eco-labeling is talked about, Bjorn Erik is one of the experts who is always sought after to speak. I myself and Mr. Karthikeyan had the privilege of interacting with Bjorn Erik when GreenPro India was certified. Bjorn Erik was one of the persons who made the assessment of GreenPro, and his guidance and his contribution to the eco-labeling network globally has been immense. And we are extremely privileged to have you, Bjorn Erik, for this program. And thanks for joining us. And we also have the privilege of Mr. Gurmeet Singh Arora, who is the National Chairman of Indian Green Building Council and the Managing Director of Rajco Group. He's a strong ambassador of green movement in the country, been involved right from the very beginning of the inception of IGBC, the Indian Green Building Council. And he's also a very firm believer in water conservation, and is a water enthusiast and advocates for improved water management in building. And his involvement in IGBC and another organization of Indian Plumbing Association has been extremely high. He has contributed immensely to water conservation and the green building movement in the country by his efforts and initiatives. We are privileged to have two stalwarts speaking at the inaugural session of this program. Thank you, Mr. Bjorn Erik. Thank you, Mr. Gurmeet Singh Arora, for joining us at this program. We nearly have 500 registrations, and the number of people who are attending the session are going up every minute. I'm sure every one of them will benefit substantially by attending this program. Without much further ado, it's my privilege to request Mr. Gurmeet Singh Arora, Chairman of Indian Green Building Council, to address us. Over to you, Gurmeet sir.
Thank you, sir. There are two persons in the chat box who cannot hear. I think we can hear each other. Am I right, Mr. Venkat Giri, Bjorn, and Karthikeyan?
Perfectly, sir.
Absolutely. Something to do with their network then. Anyway. Well, a very good afternoon to all of you. I am really privileged to welcome Mr. Bjorn Erik Lawn, Chairman, Global Ecolabelling Network, Mr. K.S. Venkat Giri, our Executive Director, CII Green Building Council. Ladies and gentlemen, a very good afternoon to you. The speech I have been given, Bjorn, says good morning. I think it must be because of you, but good afternoon to all my friends in India. It is indeed my pleasure in welcoming all the delegates to this very important seminar on low carbon building products and materials. And as you know, you cannot reduce the cost of green buildings unless you have eco-labeled products equally available in large quantities in a country where you have the green building movement. So both play a very important role in the green building movement. And I would like to extend my personal thanks to Mr. Bjorn Erik, Chairman, Global Ecolabelling Network, for joining us today. Thank you, sir. To this August gathering, I would like to share the initiatives of IGBC that facilitated the growth of green and healthy buildings in the country. Well, for many of you, we started in 2001, that's 21 years back, with one building of 20,000 square feet. At that time, this building costed us 18% more over a conventional building. We have enough evidence to show now that green buildings actually cost less than conventional buildings, because there is now localization, there is production of green products, more than 4,000 products now certified by the GreenPro Council. And certainly the cost of products has come down, and therefore the cost of actually making a green building is much lower than a conventional building. So it makes business sense to actually build green now for developers or to design green buildings for architects. Today, I am proud to tell you that we are not only the largest green building council in India with more than 92% market share, we are at 8.18 billion, 818 crore square feet of green footprint. We are the second largest green building council in the world, but we are not going to stop here. Our aspiration is to lead the green building movement, not in India, but on Mother Earth in the world. And I'm pleased to inform you now, IGBC is represented in 21. You know, India, if you take beyond India's map and put it on the European map, we'll cover 2/3 of Europe. So if you look at the length and breadth of India and the population of 1.35 billion going up to 1.5 now, IGBC has achieved a lot. We have 29 chapters. We have chapters in the east of India, west, north, south. We are represented all over in all the big cities. I am pleased to also inform you that we have a big connect with local governments all over because of our chapters, and also the central government, where we are working very closely with them to ensure that we not only green the built environment, but we are greening cities, towns, and lots of areas, maybe the new town, which is a big area where there are lots of development taking place in Calcutta. So lots of cities are now coming in where the IGBC and both GreenPro are being specified. We have launched 30 unique green ratings for different built environment. We have a green village rating system. We have green interiors, green logistics, residential, factory buildings, schools, metros, railway stations, cities, towns, hill stations, you name it, IGBC certified, even petrol pumps. Even a single petrol pump or a single police station is certified by IGBC, because we do not even want to leave either the retail segment or the wholesale. We want to do it all. We have to convert every building in India to green. And I'm going to tell you how we are going to go net zero. The government of India pledged to go net zero carbon for India or achieve carbon neutrality by 2070 at the COP26. IGBC has much aggressive targets, and so does the GreenPro. We want to become net zero energy, carbon, waste, and water for all buildings to be built after 2030, and net zero for all existing buildings, which is much tougher, up to 2050. So we do not want to see even one building in our country, whether we have to bring in legislation or we have to make sure developers change and go for green certification. We as IGBC and Confederation of Indian Industries do not want to see even one building or one built structure not to be certified as green, and not to be certified at net zero. Forget green. There's a lot of difference between net zero and green. We want our country to be net zero for all the built environment, which gives out nearly 38% of the carbon today. 38 to 40% comes out of buildings, as we are all aware. Given the global focus on climate change, India's commitment at COP26, IGBC is committed to move towards net zero buildings and built environment. Just last year on Earth Day, on 22nd of April, we launched the IGBC mission on net zero. You'll be pleased to know even our headquarters, where Mr. Venkat Giri and Mr. Karthikeyan are sitting today, is net energy positive. We are having more than 100 staff there. Okay, my colleagues, more than 100. It's an air-conditioned building. It's not that we are working in candlelight or something, but it is a net energy positive building. So if we can do it, and why can't others do it? After all, whatever the installation cost, you recover within 1.5 years. So everybody who's on this webinar today, we have to make sure that every structure that we construct must be certified green, and IGBC is there to handhold you. As part of this net zero mission, more than 300 leading large organizations from the Indian building sector have committed to achieve net zero status for the new and existing buildings. So it's not just we are a lot of companies are walking the talk. There are lots of companies which are now going for net zero water, energy, waste, and of course carbon in future. Low carbon products and materials will play a very significant role in achieving net zero target. Without low carbon, without low embodied energy, without low embedded water products, we cannot have a net zero target. So both have to play hand in hand. Both green products and green buildings have to support each other, and that's where the real growth will take place for green products in our country. The buildings aspire to achieve net zero status must first reduce embodied carbon by using low carbon products and materials for construction, and reduce operational cost by utilizing resource efficient technologies. The next step would be to offset residual carbon by implementing mitigation measures such as investments in on-site, off-site, renewable energy, carbon sequestration, so that we are able to achieve a balance, because we may not be able to do everything on-site, but we can always do it off-site. IGBC, along with GreenPro Council, is supporting the stakeholders, architects, developers to select products and materials with low carbon footprint, and that's where We have developer associations in India, CREDAI and NAREDCO, designer associations like the Council of Architecture, the teaching of architects, 480 architectural colleges in India. Can you please mute yourself, everybody? And the 44,000 Indian Institute of Architects, the 9,000 Indian Institute of Interior Designers. We are working with all these associations to make sure that all of them only specify net zero. Lowering the carbon footprint of products will reduce the building carbon footprint, but also reduce the carbon footprint of the entire building sector and contribute to reduce carbon emissions at the national level. This will create a win-win situation, not only for buildings, for manufacturers, but the country at large. IGBC has set distinct goals which augurs entirely in line with the national priorities. That is to work closely with stakeholders to advance the net zero movement in the country. And we wish to work closely with central and state governments, which we are doing, but we are furthering our relationships with them for promoting low carbon products. Now, before I end, I will want to give you a quote. I'm just opening that. This quote is by Malcolm Turnbull, and he says, "Climate change, ladies and gentlemen, is not my problem. It is not IGBC's problem. It is our problem. It is a global problem. The planet is warming because of the growing level of greenhouse gas emissions from human activity. And it's not my activity, it's your activity too. If this trend continues, truly catastrophic consequences are likely to ensue from rising sea levels to reduced water availability to more heat waves and fires. So ladies and gentlemen, it is up to you. You have to decide your future and the future of your children and their children. Thank you very much. Thank you.
Thank you, Gurmeet ji, for very brilliantly articulating the India's position as well as the initiatives of the Indian Green Building Council. Thank you very much. Now, may I request Mr. Bjorn-Erik, Chairman, Global Ecolabelling Network, to give his special address. Bjorn-Erik, as I mentioned earlier, is one of the stalwarts of the global ecolabelling movement, and we are privileged to have him address all of us and educate us on his views on low carbon building products and materials. Over to you, Bjorn.
Thank you very much. Thank you very much, Giri, and thank you both you and Mr. Singh for the kind words of introducing me and the work I'm doing. I had the pleasure to visit both the office in Hyderabad and then also the conference in Jaipur in 2017. And saw there also the wide engagement that you have in the building industry in general for making a change, making it green. And from what I learned from the figures, Mr. Singh, the development has been very rapid during these 5 years and still going on. The Global Ecolabelling Network had the pleasure to have GreenPro as a member from 2017, and the growth also in number of products and companies that has joined the GreenPro with ecolabelling their products is very impressive. It's I think the fastest growth rate among GEN members during these 5 last years. I assume also that when the figures for the IGBC in volume and number of buildings that are certified in IGBC, is that this is significant for a development in general in the Indian society, and that is naturally very important because of the big population and the natural carbon footprint that the development of the society brings around. The focus on carbon footprint is global and must be global because the greenhouse gases don't know any boundaries, and the impact is by that spreading all over the world. We have also learned these very, let's say, hazardous consequences of the rising temperature with floodings and storms all over the world. I mean, the dimensions in India with the floodings in east, the heat in the west, is naturally something that we also follow here up in the Nordics, Northern Europe. Here, the consequences are not that dramatic as it is in a tight populated country like India, but we have the example. Only yesterday I learned that the highest temperature rise during the past 20 years, the highest on average over the year, is actually in the northern part, and it's on measured to be over 5 degrees already in the northern part of Svalbard Islands outside west of Norway. So it is in the northern part that the changes are the most dramatic, with the melting of the Greenland ice cover, and also the precipitation is focused now in the northern part to wrong seasons, so to say, to gain the ice cover, which is one of the biggest water reservoirs on the globe. Building materials like cement and steel or glass are traditionally produced with a high carbon footprint, and the changes you are making with the requirements for both the seeing the possibilities in changing the materials in use, the material efficiencies, and focusing on recycling the materials, and then naturally also in using renewable energy sources for the production of the big building material quantities needed, is reflected in the eco-labeling and the requirements. The eco-labels are in a place to be as an information, a reliable third-party information from the manufacturer, the producer, or the companies selling the products towards all kind of buyers, both from the private consumers to the procurers in big companies like in construction companies, and also for the public procurement. By this credible information given by the eco-label, it is a credibility that is brought up in the and against the greenwashing that is growing globally, because everybody is now learning that we have to make the consumption and the production greener. And the eco-label does not only cover the carbon issue, it is also to avoid a burden shift. We have to consider the chemicals in use, hazardous chemicals, reduce them, and also other issues from an environmental point of view important, like biodiversity, reducing the land use, and having a proper consideration of all the environmental issues. That is covered by the eco-label. And naturally, today the theme is how this eco-labeling is supporting the low carbon industry in the building sector. And that building sector is as important in India. It is also here in Europe, being among the biggest sectors of both resource use, energy use, and then you have the time perspective of buildings being constructed for decades use, and the use phase is also naturally after the construction very important to consider in fighting the carbon footprint. So I congratulate both GreenPro and the Indian Green Building Council with very impressive development during these 5 years. I've learned to follow you and wish the rest of the day all the speakers welcome to present their views of the issue for today, low carbon building products and materials. So best wishes here from Norway, the cold north.
Thank you, Mr.
Giri, can I interrupt 1 minute, please? Beyond, you have to write it down in your diary, 20th of October. The figures that I quoted today will change drastically before 20th of October. We are in June now. So we have July, August, September, October. We have the Green Building Council IGBC annual conference. Last year, we had more than 7,084 delegates online. And when we had the last physical event pre-COVID, we had 2,750 delegates registered. So I would request you, and I would like the honor of welcoming you to the Congress. The inaugural is on the 20th of October. And this is going to be inaugurated by the Minister of Housing and Urban Affairs, Mr. Hardeep Singh Puri. So it would be our honor and pleasure if you can come, sir.
Thank you very much. I will notice that, and I also ask Kate Harris, our secretariat, to notice that, because actually this week we also have our internal meetings for the Global Ecolabelling Network, and we will then make place for this possibility of joining you in your meeting in the IGBC.
Thank you very much. If you can send a formal code, please.
Sure, sir. We will do that.
Yes. Thank you.
Thank you.
Thank you, Mr. Bjorn-Erik. Thank you, Mr. Gurmeet, for both of your brilliant addresses, I must say. Thanks, Bjorn-Erik, for recognizing GreenPro as one of the fastest growing eco-label in the last 5 years. One, I must acknowledge the support we received from Global Ecolabelling Network and from seniors like you who have been working in this field for a long time. It was your knowledge and guidance which has made this possible. And of course, we have a long way to go to reach the levels of Nordic countries in terms of the number of products to be certified. But however, we are on the way, and we hope to exponentially increase the number of GreenPro certified products in India. And with leaders like Mr. Gurmeet Singh Arora, with aspirational leaders like Mr. Gurmeet Singh Arora leading us, I'm sure the numbers would substantially increase in the future. Thank you once again for your presence, Bjorn-Erik, and Gurmeet Singh Saab for your support and involvement in this program. With this, we come to the end of the inaugural session of the seminar on low carbon building products and materials. We immediately have the technical session following. I would request my colleague Pratik to take over and coordinate the next session on net zero carbon buildings. Over to you, Pratik. Thank you, Bjorn-Erik. Thank you, Gurmeet Saab.
Thank you, sir. Thank you. Oh, Pratik, you are not audible.
Now, sir?
Yeah, it's clear now. Yes, clear. You are audible.
But I'm not able to hear. Just a second, sir.
But we can see you, Pratik. We can hear you.
Perfect.
So
Now we
carry on.
can. I can hear you as well. So first
Yeah,
of all,
yeah.
thanks to Gurmeet sir and John Eric sir and Kiri sir for setting the mood for this first technical session. Let me share my screen and start with the technical session itself. So our first session is on net zero carbon buildings. And as this term is like being used or like is talked upon a lot right now. And the main reason or one of the main reason is our Prime Minister, Mr. Narendra Modi, has committed 5 main agenda items for India for their future of sustainability, comprising, we are calling it Panchamrit in India. So the fifth or the main commitment, which is like getting the net, making India a net zero nation by 2070. So this has actually helped us, or like this has actually bring awareness or made India more conscious about making green buildings, green using green products, or you could say taking sustainability initiatives to start with this. So for this specific agenda or saying net zero carbon buildings, we have set this program or this session where we have included 3 exemplary speakers, starting with Miss Architect Sheetal. She's going to bring an architect perspectives towards the net zero carbon building. Then we have Miss Kate Harris. She's from Global Ecolabelling Network, and she's going to tell how eco-labeling would set the mood, would help out in bringing out the net zero carbon buildings. And then we have S. Karthikeyan. He's the principal counselor. He's responsible for GreenPro Ecolabel. He'll be briefing about how green buildings are, what would be the future of the green buildings, what would be the best way to achieve the net zero carbon buildings. Moving ahead, without wasting any time, let me introduce Architect Sheetal. So she's managing partner at Aeon Design and Development LLP, a graduate from Sushant School of Architecture, of Art and Architecture. Sheetal is an accredited green building professional. She's chair of IGBC Delhi chapter and member of IGBC Executive Committee, and has worked extensively in designing and promoting green buildings. She is also president of WICI, which is Women's Indian Chamber of Commerce and Industry, Architectural Council UP chapter. Sheetal has been a convener for material chapter of the new sustainability chapter of the NBC as well. Sheetal is a firm believer in sustainable architecture. Therefore, her designs focus on harnessing nature's element and balancing environment consciousness with occupant well-being and comfort. Several of her projects have received LEED Platinum and Gold rating. She has experience of around 23 years and designed over 100 plus projects covering a staggering 50 million square feet of built space. Her wide portfolio of work ranges from master planning of large townships, mixed-use developments, to architecture, interior design of corporate offices, SEZ, hotels, experience centers, hospitals, residential housing, and private residences. Shunya, India's first net zero energy home, is one of her research development projects. Made completely out of waste, her projects have set a benchmark in energy efficiency in the industry. So, Architect Sheetal, I would like to welcome you to this session, and it's over to you. You can share your screen and present.
Thank you so much for the introduction. Good afternoon, everyone. It's a pleasure to be on this platform. I'll just share my presentation and my experience as an architect on sustainability and green buildings. Can you see my screen?
We can see your screen, ma'am, but it's not in full screen. Right?
Okay, 1 second.
Perfect, ma'am.
Yeah, okay. Yes, so I like to share my experience, my journey of Shunya towards zero energy society. In Ashloka say that whatever we do, it should be for the well-being, upliftment of everyone. It's never for myself, it's always for the complete society. So coming to buildings, do you really know how much energy a standard house of about 5,000 square feet would consume? It's about 3.6 to 5 million megajoules. And the operating energy of the same house would be about 5 million megajoules per year. So for people who build a house and demolish it in few years, the amount of energy which is gone for that house is humongous. And all that waste just goes to the streams. It also depends on the kind of material that you use. Greenest are the buildings which already exist. So adaptive reuse of our already rich heritage is the best way forward. So because you're not going to use any embodied energy because there'll be no new material that you'll be using. It's a good example. The right side top image is an old church which was converted into a beautiful library, where the complete building was retained as it is. The next is when you can reuse the materials in their original form. That left building is actually made out of shipping containers, which has been converted, reused and converted into a house. And there are many more examples how you can reuse a product in a beautiful way. We are in the times where aesthetics and environment can go so beautifully hand in hand. You don't need the richness of those Italian marbles or imported products to make anything look beautiful. If you look at the hierarchy of how you need to select materials, the first, as I mentioned, is the material reuse. Then is when you use materials which have high recycled content. Then use materials which are recyclable, which are natural and plentiful, locally available so that you reduce the energy in transporting them. Next are using materials which are rapidly renewable, like bamboo, which grow very fast. And then using very low embodied energy materials. Because in a house or in a building that you construct, like I mentioned, in the first year, the embodied energy plays a very significant role in for that house. And when you have to judge a material, when you talk about embodied energy of any particular material, it needs to see the complete life cycle, right from the extraction of that raw material to its design and production, to its packaging, to the use and maintenance, and then reuse and recycling. The energy that material will take in that entire life cycle has to be seen as an embodied energy of that product. So there are certain products which are very high in their embodied energy, like your metals, aluminium, stainless steel, which rate very high in the embodied energy. Then there are materials which are medium energy, like your lime, clay brick, tiles. And then there are low energy materials like fly ash, sand, aggregate, etc. So let's say you want to use metal. The best way to use metal is having a high recycled metal, because that will have less embodied energy, and metals are easily recyclable. And the way you use them should also be such that you can reuse it later. So if you use, instead of welding them, if you use nut and bolt, if you use bolted sections, which can be reused again, so then over the entire life cycle of that product, the embodied energy of that material becomes much lesser. When you use cement, concrete, you can use recycled aggregate in the concrete. When you use bricks, let's say a rat trap bond would use far lesser material and energy as compared to a regular brick. A fly ash brick would have a lesser embodied energy than a regular clay-fired brick. So these things have to be evaluated when you are choosing a product for making a building. But that's not the only thing that you look at. When you evaluate, and you have to judiciously select a material, you have to look at all of these factors. Let's say I have a window, and now in that I have a window section which I need to use. Now the frame, I could either use an aluminum, I could use UPVC, I could use another material, let's say wood. But if UPVC over its entire life cycle is able to save me the operating energy of that building by reducing the heat which comes in, and for our climate, and the cold which comes out, then it may be a better product to use over an aluminium, which will get in more heat, and I will eventually be using, more energy over the entire life cycle of the building. So everything has to be evaluated. And then how do we install that particular material? Can I reuse it again? That also has to be thing. We have to look at the durability. What if I use a material which may be very low embodied energy, but it's not durable, and I have to keep changing it every few years? Then the whole point is lost. So as an architect, as a user, we have to look at the material in the entire paradigm, like looking at the complete life cycle of that product. Now that was about the embodied energy of a building, but it's not the only thing. When you look at sustainability, you have to balance the economic, the environment, and the overall well-being of the occupants who are going to occupy that building. So coming to the operating energy and the overall holistic approach to a building design, we realize that, how our ancient buildings were. This is a very beautiful example of a temple, how we used to build temple. There was this shikhar, there was this point bindu where the complete apex of the temple was. That was called the energy center, where the heaven and the earth would meet. It was the energy center where the entire power was transmitted. And just below that was the idol, the Garbhagriha, what we call it. That was getting that energy. So this was called Shunya. It was called the epic, the center where the complete creation and destruction happens. It's the power center. The first understanding, as I mentioned, when we look at sustainability, you don't only look at energy, you look at the holistic picture. You see that, because they're going to be the building that you design, that there will be occupants who will inhabit it. Their well-being is as important as the environment. So we have to balance all of this. For example, if I'm designing an office, and the best way to protect the environment would be that I give hardly any windows, because then the heat will not come in. I will not be burning coal to generate energy for that building, because that'll be least amount of energy that would require. But what about people who are going to inhabit that building? If they don't have natural light, if they don't have connection to nature outside, if they don't have that diffuse daylight coming in, it will affect their well-being. It will affect their overall psychology. So then it's important that we give glazing, but we give glazing in a way that we don't, for our particular climate, we balance that window wall ratio. We only have, we use probably a high performance glass. We shade the glass according to the sun direction, so that there's minimum heat which comes in. And that minimum heat, then we try to remove by using the most efficient and effective equipments. So then you are balancing. I mean, that's a smaller scale that I'm talking about. Second understanding is how we used to build as per the climatology. When you build as per the climatology, as per the sun direction, as per the wind movement, these buildings would shade each other so well. They will have smaller openings so that, they would have jali in front. So by venturi effect, they would cool the wind which comes in. They would have a courtyard, which would allow to shade the walls. They would allow to cool the air, which is, inside. And that's courtyard space would have a multi-function. These days, when we build, we need one room, we'll make 10 rooms. Earlier, they would have multi-function of the same space. A vada or a outdoor space was also used to meet your neighbors, interact there. It was not a space which would lie dead throughout the day. The same area, a square or a chalk in a village, would be kept for a multiple use, throughout the day it would be used. Morning, maybe they were selling vegetables. Evening, there were functional things happening, get-togethers which were happening. So that's important. The third understanding is that nature is very, very powerful. When we build in line with nature, we build something which is more sustainable. The power of nature is that it can transform a very simple thing into poetic. It helps to uplift our spirit. In fact, there are so many studies done where they say that people, the patients heal better, students perform better when they are in tune with nature, when they are connected to nature, when they have views of nature, when they can go out to nature. In fact, I was looking at a very beautiful design lately of a hospital where they have, they have beautiful courtyards all interlinked, and every room, goes out into a lovely landscape area. So patients can actually go and they will be spending a couple of hours outside. That's the main thing. So that will be the main healing power. Then the biodiversity, the wetlands, forest land, ecology. Nature is so powerful that half your problems will be over. In fact, there's a project that we have done where we've used these bioswales to recharge water rather than using stormwater lines, putting pipes. You can really reduce all of that. And nature is timeless. It's beautiful. There are texture, pattern, colors. So connecting your buildings, having nature in touch with you for your everyday life is very, very important. Designing urban environments that respect and engage those natural systems by bringing ecological infrastructure aesthetically to create more beautiful social spaces. That'll also lower the temperature, that help to recharge water, that'll give you so much of fresh air, and where you rely less on pollution. Reducing the pollution, that's the best way. This is a very interesting example. If you see in the lower picture, where there was an existing nala which they've converted into a beautiful stream, and the ecology and the economic of the place has really become much better. And interconnected spaces, social spaces. This is a project, Green Boulevard, where there was, instead of one large building, that one tall building with the developer wanted to build, these are series of three buildings which shade each other, and the ground floor we have stilted. So, and we call it a nature's walk, where people walk through these these spaces before they go into their offices. There are water bodies along the wind direction. They cool the space very nicely. And then you actually, even if you go in peak of June, you'll find people sitting outside. It's changed the way office space is perceived, where you amalgamate your office spaces beautifully with natural areas. The buildings, of course, are very well efficiently designed. The footprint is such that it's able to capture natural light from both areas. The buildings, south and west side, is sandwich walls, which are AC walls, which AC block aerated concrete blocks, which are much lightweight, consume less concrete, are lower embodied energy, and also in turn help to lower the temperature inside, because they help in insulation as well. The complete glass is nicely shaded. The window wall ratio is only 30%, as against 50-60% that you see all around, which gets in too much heat and light. Now this gets only a diffuse light. There's more glazing towards the north. There are these beautiful social spaces which are there, which lower the temperature. These are the building simulation models, which from where we could predict day one, how much energy this building which actually consume. So instead of 200 square feet per ton, this actually gave us 800 square feet by just 1 ton of air conditioning. And this was how the very high energy performance building this was. And these are the various factors which contributed to lowering the overall operating energy of this building. It operates as 1/8 of what a regular neighbor building would do. This is another project which is IGBC's first platinum building, which is called Patni Computers, and it saves about 35% compared to a ASHRAE based case, and almost 50% as to a standard Indian building. It's a very nicely shaded building. There's a complete diffuse light which comes in. There are 2 courtyards which actually bring in that light. There are light shells which actually get the diffuse light, cut the glare which comes in. Then there are water bodies, jalis, which actually get cool air inside into the courtyard through Venturi effect and cool this space completely. Again, inspired from our ancient architecture we used to have. Then these are the simulation models which lower the operating energy of this building significantly. And at the same time, the materials used had very high recycle content. The walls were all of aerated concrete blocks. And in terms of equipments, also these were high energy efficient equipments that we use. There were fresh air dampers which were linked to CO2 sensor. We were using pre-cooling and free cooling in fair weather seasons to actually lower the air conditioning cost also. So you see all these buildings were very high energy performance, but we wanted to do better. So this is another project where the client wanted to break the building and build a new one. And we said, no, you retain. This was how it used to look. A lot of glass, but not much natural light inside. So they had beautiful garden, but they were not put to much use, because these were all glasses which were fixed. No one could actually go out and enjoy this place. So this is an atrium which had a lot of glare. So we revamped the office. We said, let's not break the office at all. Reuse it. We use the core and shell of the building. We only redo the interiors. We changed the facade to make it more energy efficient. And so that's what we did, the facade studies, to ensure there was no glare coming in. That's how, the facade is now, with these fins which modulate to give it interest, and at the time, shade the sun which comes in. So that's how the outdoor area, which is now much used, because now we have doors which open up into these spaces. We have cafeteria, which we got down from the second to the ground floor, so people could enjoy this outdoor area more. So the load on the cafeteria would be much lesser. And there are a lot of people who work out of this place, outside area also, because this is a north side, it's nicely shaded, and that allows people to work outside, saving again more on the operating energy. And then this is the west facade, which is nicely shaded. This is the atrium now, which has a double insulated roof glass, which also has shading system. We got introduced plants inside so that people can enjoy that. There's more fresh air within, and there's more oxygen inside these spaces. Then this is another campus where we are, we studied how the shading, the wind direction would help cool the place. There was an irrigation canal which we are filtering the water and using for the recreation purposes, so that when the wind blows over it into these spaces which have these cuts, the wind direction is from here towards the other side. It actually cools the space. This is the jali screen which shades the interior. So overall, it really helps to effectively reduce the operating energy of the building. So these are all high performance buildings, which got platinum rating. But then we wanted to do better. We said, let's attempt to go the net zero way. A net zero building will be a building which will consume, which will generate as much energy as it consumes over the entire year. So this was a project, Shunya, which was way back in 2008, that we used out of waste containers. We took 4 old waste containers, designed them around a courtyard. Courtyard works very well in our Delhi climate. We made verandas out of the center two courtyards, two containers. And the first container was mainly the entrance, kitchen, and toilet, which were non-air conditioned. The other containers were air conditioned. And this is about 1,000 square feet of built area. And we had just 1 ton of air conditioning that we use. And I'll just, go through how we brought down the carbon footprint of this building. So we took this building and saw that what was the electrical load, which was 8,500 kilowatt hour. Cooling load was 2 tons, and carbon emissions were 7.6. We first corrected the orientation. So it was just a model first we started with. We corrected the orientation, and we realized that we saved about 2% energy. We insulated the roof, and we saw that we saved another 2.5% energy. Then we insulated the walls. We saved a cumulative of 11% energy, 6.5 just through the insulation of the walls. And the carbon emissions also, you see, dropped down, which is the last line that you see. We introduced double glazing, which saved another 4% energy. Then we went on and we changed the window wall ratio. We reduced that. We saved another 4.5 energy. Then the complete daylighting was through the courtyard, natural and diffuse light that we got through the courtyard. We introduced daylight sensor, occupancy sensors, shading devices, saving another 5.5, cumulative of 3.1, and then 31%. And then there was improvement in the carbon emissions. Also, you see they dropped down. Then we went on and introduced some plantation in the courtyard, introduced louvers in the courtyard. And then we saved some more percent energy. Then there was natural ventilation we did for the entrance and the area, which is the kitchen and the toilet and the entrance container, which saved another 9% energy. We used the solar AC, which saved another 20% energy. We used the 5-star rated equipments, saving another set of energy. So overall, if you see, we really brought down the energy consumption. There was a huge saving there. Then carbon emissions also brought down to almost zero. Then because the remaining energy that this this house actually used was brought down to 3 kilowatt per hour, and that was through the solar panels which were installed in the roof. But more than that, so once we attained all of this, this was the chart which shows their PV generation energy consumption. It was not just about energy, it was about zero water, zero waste, and zero zero energy. So we had a vegetable garden where you could grow your own food. You had a composting pit where all the organic waste went, and the same manure was used within the premises for these gardens. So it was again a closed loop, zero recycling that we were talking about. Water also, there was again a complete reuse of water. We had a roof garden, we had vertical gardens to reduce the heat and cool the winds which would come in. And then of course it gave rise to more birds, more flora, fauna. So that's how the house actually looks like. And this was an experiment which was done. Every set of furniture piece that you see is an old furniture which is put to adaptive use here. And that's the courtyard. That's how, you see this all bamboo flooring there. So we took this experiment which we did. We ran this house for 1 more year after it was built, and it was done very successfully. Then we took it to another office that we're doing in Calcutta, and again studied the sun, wind directions. This is an office which actually the complete facade generates as much energy as it would consume during the year. It's again got a nice marshy lands here, and there's a concept of borrowed landscape where the ground floor has this cafe and outdoor spaces where these umbrellas are also solar. They are on the south side, and they're solar umbrellas which would shade where people are sitting, and they get a beautiful view of the marshland while the site is actually very small. So that's what we call as a borrowed landscape. We have a roof terrace garden which is also having solar panels to shade. The outdoor spaces will also have these solar panels which would light up the entire thing. So these were the analysis which we did. And first, the intent was to bring down the energy consumption of this project to what we could actually, to the bare minimum that we could do. So this is the final EPI of the project, which was 67.3 kilowatt hour per square meter, which is actually generated through the BIPV and rooftop solar. And so in the end, I would like to say that, of course, we can only progress if we go the carbon neutral way. And already our Honorable Prime Minister has declared that, we are looking at 2050 as carbon neutral, and by 2030, we have to significantly, almost 50% reduce all those emissions. So we envision India as a zero energy, zero water, zero waste society, and a minimal carbon footprint and earth-friendly society, which will lead from front. Thank you.
Thank you so much, Sheetal ma'am. It was a great presentation. I think in last few minutes, you have touched almost every aspect of a green building. So thank you so much. We've been getting a lot of questions in the chat box, but we have this question answer session. So I would request everyone to ask their questions in the question answer session after all the 3 presentation of this session. So in the meanwhile, I would invite Ms. Kate Harris. Just let me share my screen as well. So I would like to welcome Ms. Kate Harris. She's Secretariat at Global Ecolabelling Network. So Kate is a passionate change maker who is committed to a future-ready society across all sectors through supporting individuals and organizations. Kate has over 18 years of not-for-profit leadership, including previously being the CEO of Good Environmental Choice Australia, which is acronymed as GECA, and Center for Sustainability Leadership. Kate is proud to be on board of the Global Ecolabelling Network and is the Australian chair of the Environmental Labelling Committee for the International Standards Organization. She is also involved in the Living Future Institute of Australia. So very welcome to Kate. It's over to you, ma'am. You can start the presentation.
Thank you very much. I'll just pull up my slides. I'm just going to try and optimize for sound because I do have a video. But we'll see how we go. I can't seem to optimize it. Can you see my screen?
Yes, ma'am. It's visible.
Thank you very much. Thank you so much for having me. And that was a very inspiring presentation just before. So whilst I work very much on that granular level of materials and products, it's beautiful to see the very meaningful design and product that they go into. So I really appreciate that. Thank you to Mr. Singh and to CII for having me. It's very inspiring to be amongst you all and hear of the leadership positions. As was mentioned, I'm the Secretariat of the Global Ecolabelling Network, actually no longer on the board because I'm the Secretariat, but was formerly on the board and very passionate about GEN. But firstly, I'll talk more around the role of eco-labels and the association and driving change with low carbon products and materials. So we saw in some of those pictures, there's lots of cement and concrete, and the challenge is, how do we actually know what good looks like? We also know there's a lot of cement and concrete, and it's the second most consumed product after water, which I still find incredibly staggering. So beyond fit for purpose, which all eco-labelled products require, and I'll go into that more, and it certainly does require some environmental consideration as well. And Bjorn Erik, our chair, spoke very much to that. The importance of actually looking beyond the surface level to understand what good might look like. Some of the tools that can be used or ascertained to work out what good looks like can be such methods as life cycle analysis, environmental product declarations, and of course we also see environmental management systems used in terms of organisational environmental efficiencies. The challenge is, how do we actually ascertain what good looks like? Particularly for those who may not be environmental scientists or able to read such data as environmental product declarations. And that indeed is where the challenge and the opportunity of eco-labels come in. So eco-labels really are a very easy, clear way of demonstrating an efficient and effective good environmentally preferable product. So it should be very easy to see a label and know that that is a better choice for people and planet for a product or service. And that is the role of eco-labelling. So where environmental product declarations or life cycle analysis might have a lot of useful quantification data, for many in the speed of effective decision making, it can be a barrier. And also even in the calculation of that data and the expense associated with that, it can be very challenging. And so that's where eco-labels very much come into role. There are a lot of discussions around eco-labels, and I think if you go on to things like Ecolabel Index, you'll see that there are hundreds and hundreds, but indeed many eco-labels that use that term are not purely an eco-label. And so when we talk about eco-labels, it is in the true sense of the word of ISO 14024 and the international standard definition. So just to touch on a high level, what does that actually mean, and the credibility and rigor that sits under the ISO 14024, because it is important to understand what this stands for and the credibility and transparency that goes with a true eco-label. So it should be voluntary. It should be on that upper echelon and is not minimum compliance. It is full life cycle based, and we'll talk a little bit more about that later. So it isn't just one aspect, or cradle to gate or cradle to grave. It needs to look at the full extraction of the product in the manufacturing, the usage, and of course, the end of life considerations as well. If something is eco-labeled and certified against a particular product, that should be transparent. The standards should be easily obtained, and in order to understand the actual achievements and boundaries that the eco-labeled product or service has achieved. And very importantly, third-party verification. So making sure the manufacturer themselves cannot actually certify and make their own claim. That is very much a different category of international standards, often in the ISO 14021, known as claims or single issue certification, is soon to be an apt descriptor. And so the importance of eco-labelling is that removal and of bias in order to make that justified decision. And it is based on credible, measurable data in order to justify. And of course, as mentioned, multiple criteria is also critical. So carbon, as Bjorn Erik said, very passionate about carbon and eco-labels, and our Gen members that I'll talk about more. If there is a carbon impact associated with a particular product or service, that must be within the standard and must be measured and reported as a key component of that life cycle impact. And in addition to carbon, we are also looking for circularity. So at what point does the carbon impact happen? Sometimes it's in the usage, even end of life, or sometimes manufacturing, and sometimes all. So the efficiency again of eco-labels is counting carbon when it really counts. So where are we having the biggest environmental impact when it comes to carbon? And making sure that we are setting appropriate boundaries. And given I'm based in Australia, near where Malcolm Turnbull lives, I certainly agreed with those comments that it is a global challenge, and we all need to do our part. And we all need to understand how to do it. And that's perhaps the biggest challenge for some. So what is our role in eco-labelling? I've talked about the ISO 14024 as an effective and efficient way to determine what good looks like. Well, our role at GEN, founded in 1994, is a not-for-profit really driving excellence in eco-labelling. So we bring in members and leading and growing capability and connectivity in order to make a global solution of credible eco-labels in order to drive best practice. So we have more than 37 members. We have different levels of membership as well. And we work with many key stakeholders in order to drive the importance of eco-labelling. So that awareness is key. So when you're talking about buildings, how are we actually specifying and working with eco-labels in that consideration? Within GEN, we have a top tier of membership, and I mention this because it's critical to understand that this is a peer review process to say that GEN has assured that level of credibility and alignment to the ISO 14024. There are components beyond eco-labelling in the verification process that you would find in the ISO 17065 as well. But I really encourage you to explore and understand more. What are the components? What does credibility look like? And that's where Gen stands on our members being, and more than 90% of our Gen members do have that Genesis peer review to ensure that there really is effective solutions and credible eco-labels out in the market. I don't think my video is going to work because I could not optimize for sound when I was sharing. So apologies. If we've got time later, I think the team have it. But look, I encourage you to look at the Look Closer campaign. This is a really short video to show that life cycle impacts for many products are not necessarily what we think at first glance, and that actually everything that we buy and consume on a granular level, micro and macro, have significant impacts that we often don't first see. So I really encourage you to look at that. I'll skip because of the sound. So when we come to high impact carbon intensive products, and we saw some of those beautiful infrastructure photos, you know, we do have to look particularly at the cement and concrete, as I mentioned, aluminium and steel as well. And so many of our members do have these components, particularly, and I know I've worked with CII quite closely and have had the privilege with working with them when I was at GECA in regards to the importance of those building products and how they fit into green building schemes is absolutely critical. So we do have a myriad of standards that our members create. And as I said, they're transparent. Feel free to go to their websites and you will see some of the high intensive carbon ones that I've put there. But of course, there are many others. And I encourage you to look at that next level to say, beyond a first glance of what might look like a high carbon intensive product, what ones actually could be significant. And sometimes they're quite surprising. So when we look at life cycle, that full life cycle approach, of course, some might be end of in the usage phase, such as home appliances and office equipment. But in others are very much in manufacturing. And I know many would say, the paint doesn't have any impact on carbon. But in fact, titanium dioxide and one of the ingredients in its manufacturing is a significant impact on carbon. So again, eco-labels do restrict the amount of titanium dioxide because of the carbon impact. So urging everyone to look beyond the surface of a product. So how do eco-labels benefit providers and why manufacturers get involved? Procurement solutions are really looking for a market advantage. They're looking to reward leaders. How can they know what good looks like? How can they ensure that they're specified into builds and construction so that they know that they're delivering on low carbon solutions? And this is really critical. And of course, sustainable development goals. So we know that at a building level, this is important, but more and more organisations are also reporting on their sustainable development goals, calculating full carbon impacts and beyond. And we know that eco-labels very much as a core speak to responsible consumption, SDG Goal 12, but touch on almost every single SDG in the suite. So when we look at things like cement and concrete and steel, they do speak to even clean water, how the water management is managed. So life below water, climate action. We heard Bjorn Erik speak of biodiversity and the importance of life on land and how that is sourced. So really there's a significant touch on many of those, and organisations can use the demonstration of use of eco-labels to also demonstrate their achievements in the Sustainable Development Goals. As mentioned, I used to be in GECA and very much in the built environment, and so I absolutely acknowledge the International Green Building Council. I worked very much with many of them, particularly across Asia and Oceania, where these schemes are critically important. So So manufacturers who are doing the right thing, who are investing in low carbon, do need that reward and recognition to continue to strive for that next level of change. And so you see the green buildings, things like the Infrastructure Sustainability Council, well building schemes. GECA is also recognised in US EPA, but increasingly organisations, insurance mitigations, they're all looking for low carbon solutions. Sustainable public procurement is also key. So beyond voluntary guidelines, we also see more and more mandatory specification, excuse me, of voluntary eco-labeled products as well. So in that procurement policy, that does create a significant shift in economic viability for eco-labels. So wherever possible, if you are able to specify and have a policy that drives eco-labelling, I really encourage you will see a significant economic and environmental positive impact. And of course, last but not least, it can't just be about carbon. We know there's challenges with carbon, even in terms of carbon neutrality. We're still struggling with an agreed world international standards definition on this. So whilst critically important, we actually don't have the time just to focus on one solution. We have to respond to carbon, toxicity, waste, broader impacts, human health. All of these things are critically important. And the less time we have, the more we need to be able to manage the complexity of all of those components of every single product moving forward. So thank you very much. That really is just a touch on eco-labels. I encourage you to look at the Look Closer campaign video, look at the Gen site, and look at some of the members to find some of the products and standards that you can work with, which really will drive to have a low carbon and environmentally better future. So thank you very much.
Thank you so much, Kate. It was a really good presentation where you covered everything about the type 1 eco-label, and you have kind of proven that how it ensures that we are making low carbon products and we are ensuring the better environmental performance of a product. Also, in the end, you showed the way ahead that it needs to be beyond carbon, and that's how we have to move ahead in the future. So thank you so much for the presentation. We'll be taking the questions in the end. For the next presentation, I would like to invite Mr. S. Karthikeyan. So he's principal counselor at CII GreenPro. He's a principal counselor in IGBC and heads the IGBC certification technical teams, and has over 20 years of experience in offering consultancy services related to energy efficiency and sustainability. He is an accredited energy auditor by Bureau of Energy Efficiency, Government of India. Presently, he is also leading GreenPro, Green Product Certification Service offered by CII GBC. GreenPro is a product certification based on a holistic life cycle based approach. He has been instrumental in conceptualizing, developing, and successfully launching the service for the Indian industry. So Karthikeyan sir, very warm welcome.
Thank you, Pratik.
Over to you, sir.
Let me share my screen. Very good afternoon, friends. In fact, the previous speakers, Architect Sheetal as well as Ms. Kate Harris, they have set the tone for my presentation. It has become much more easier for me. This presentation is focusing on the low carbon products and materials for reducing the carbon footprint of the building. When we talk about the carbon footprint of the building, though the presentation says it is embodied carbon, if you start using the low carbon products and materials, in fact, you will land up in addressing both the embodied carbon of the building as well as the operational carbon. You know, if you do the life cycle analysis of the building carbon footprint has got a major three parts. One is the embodied carbon, which is on account of the products and materials you use as part of the building for constructing it. The second thing is the carbon emissions during the construction process. Of course, this is a very, very minuscule part if you consider the whole life cycle of the building for about 50 years. But still, there is some amount of energy and resources going on during the construction. So during the construction, there is some amount of carbon footprint. And third is more important, which is an operational carbon. So which is mainly on account of the resource consumption for the operation and maintenance of the building. So if you look at the building life of about, say, 50 years, if you start accounting the embodied carbon, the carbon emissions during the construction, as well as the operational carbon, especially for commercial building, the operational carbon contributes very significantly in India. The operational carbon for about 50 years, if you look at that, contributes about close to 94-95%. The remaining about 5% goes for the embodied carbon. But though it looks very small from the building point of view, but if you look at from the country point of view, the nation point of view, the supply chain of these buildings, they contribute significantly for the overall country's emission. Whether it is cement, concrete, or steel, they contribute significantly for the overall emission. That is the reason we give a lot more importance for addressing the carbon emissions as part of the supply chain as well. So looking at this scenario, we can start working on in terms of how to go about with respect to the low carbon building. What is this low carbon building all about? If you look at what is a low carbon building, obviously the building should have the lower carbon footprint, whether it is embodied carbon or the operational carbon, both put together, the building should have the carbon footprint as low as possible. So what are the things it has to do? Number one, obviously, in terms of the natural resource consumption, the building should have a very low natural resource consumption and should make use of the low carbon products and materials as much as possible for the construction of the building. The second aspect for reducing the operational carbon footprint, it has to have the best of the energy efficiency so that the energy consumption is very low. On account of that, the footprint is also low. And second, it has to make use of the renewable energy as much as possible so that the carbon footprint can be brought down further. And this can even a building can aspire to achieve a net zero carbon building. You know, if the building is able to offset the entire carbon emission on account of its construction as well as the operation and maintenance, that is also possible. We are working on the framework and then we will take it forward. So the point is, as far as this presentation is concerned, I am going to focus more with respect to the products and materials which are contributing for the embodied carbon of the building during the construction. What are the things we can look at? How we can look at in terms of reducing the carbon footprint? But incidentally, friends, when you start using these low carbon products, it not only addresses the embodied carbon, it also addresses indirectly the operational carbon. For an example, if you take construction block, I just to give you a comparison here. You know, the conventional practice in India is to go for a red brick, a clay brick, to go for construction of the building. The second is people also start using the fly ash-based bricks, and there is something called AAC blocks, autoclaved aerated concrete blocks, that is also available. If you look at in terms of the carbon footprint of these blocks, see, for an example, in case of a brick kiln, what we need to do is we have to dig out the clay, it has to be cut into bricks, and then you have to put it in a kiln where enormous amount of energy has been used for baking it. So obviously, the energy footprint or even the carbon footprint of a brick kiln is much, much higher. Whereas suppose if you take an AAC block, in case of AAC block, what happens is, you use close to about 75% the fly ash material and about say 24% of cement and then 1% alumina for aerating it. And then there is no need for baking the brick. What they do is they mix all these mixtures, cut them into the bricks, and then it is put in oven where steam has been supplied to take out the moisture. So obviously, what happens is there is during the mixture itself there is an aeration happening. The brick becomes very porous, lightweight, and then the moisture has been removed. It can be even sun dried. So there is no need for putting this in a kiln to bake it. So because of this reason, what happens, the embodied carbon of these kind of products is much lower compared to a conventional brick. It is only about, say, 300 to 350 kg of CO2 per ton. And another aspect is there are a lot of thermal insulation property attached to this, because this is porous, and because it is porous and lightweight, what happens, the U value of this brick is much better than a red brick. For an example, in case of a red brick, the U value is about 2 watts per meter square degree Kelvin. In case of AAC block, it is as low as about, say, 0.75 or 0.7 watts per meter square degree Kelvin. That means a wall which is constructed with the support of a AAC block will allow 1/3 of the heat to pass through. There was one question from the audience, how to reduce the heat gain in the building. This is one way of doing it. If you make the envelope more thermally insulated or more efficient, obviously you will be able to bring down the heat gain into the building. So it has got an excellent thermal insulation property. I will just show you some results, how things are working. See, for example, we have done the simulation of a building which is made by a brick wall, a red brick, and also a similar building which is made with the AAC block. When you do the simulation for the whole year, a building which has been made with AAC block has got an energy consumption about 4 to 5% lower compared to a building which has been made with a red brick. The 4 to 5%, it may look a very small number, friends, but this is for the lifetime. The lifetime of the building, you are able to bring down the energy consumption by about 4.3%. So obviously, see, we did this for only a small building. When you go for a multi-story building, in case of a commercial building, the energy consumption reduction will be much more significant, and you will also be able to optimize the cooling load and then the air conditioning capacity, etc. And obviously, because of the reduction in cooling load, here you are gaining two aspects. One, because I am going for an AAC block, I am able to reduce the embodied carbon. Second, because I am able to reduce the cooling load, I am also able to reduce the energy consumption, and hence the reduction in the operating carbon footprint as well. So the lower emissions we are able to achieve in both the aspects. Very similarly, I want to take some more examples here. See, for an example, cement is a common material we use in building. Without cement, you cannot build a building also. So generally what people do is, there is a tendency to go for an ordinary Portland cement. There are different types of cements available, and these cements contribute for obviously a significant amount of carbon footprint. We all know cement is a very cement making itself is an energy intensive process, and it leads to the carbon emissions more. There are, let us say, different types of cements. One is ordinary Portland cement, which is supposed to be a very pure cement, and second is Portland Pozzolana cement, PPC we call it as, which has got fly ash to the extent of about 35%. When I say fly ash to the extent of about 35%, that means to that extent, the ordinary, the clinker requirement comes down. So because of that, the carbon footprint also comes down. See, for an example, if you take ordinary Portland cement, let us say the carbon footprint is about, say, 800 kg per ton of cement produced. In case of a PPC, it is only about 650 kg or anywhere between 600 to 650 kg per ton of cement. So obviously the carbon emission is lower. Another aspect is, because we are using the cementitious material in this, the strength gain also over a period of time it happens. It is in fact much better than an ordinary Portland cement. In case of OPC, we have some cement experts in the next panel. You can have more information from them. But the point what I am trying to say is, in case of OPC, you may gain some one-day strength, whereas in case of PPC, the strength gain is much more over a period of time. So we always recommend going for a blended cement compared to an ordinary Portland cement. Very similarly, there are other options available. So Portland slag cement, if you look at, the slag can be added to the extent of about 70% as per the BIS standard. So obviously the carbon footprint comes down even much lower. And then if you look at the advantage compared to OPC, there is a increase in durability, and also it addresses the corrosive, corrosion related issues. And even in terms of thermal cracking, it is a much better cement compared to an ordinary Portland cement. So the point what I am trying to say is, apart from looking at a reduction in carbon footprint, obviously if you go for blended cement, there will be a reduction in carbon footprint. But apart from reduction in carbon footprint, there are much more benefits in terms of increase in strength and also durability and the corrosive resistance related properties. There is another cement that is available, composite cement, which is gaining a lot of importance nowadays, wherein both fly ash as well as GGBS has been used for making the cement. The carbon footprint of this cement is even lower. The workability is much better compared to the other cement. So the lower heat of hydration and shrinkages, very good corrosion resistant property. But obviously, it reduces the embodied carbon of the whole building. Friends, it is not only reducing about the embodied carbon. When you go for these blended cement, you will also be able to reduce the cost of construction. Compared to an ordinary Portland cement, these cement products have got a lower price because of an increased additives. You can have a cost comparison at the market as well. Of course, there is a exclusive presentation in the next session on the ready-mix concrete. I don't want to go deeper into this, but still I will highlight how the carbon footprint can be addressed as part of this. Variety of concrete mixtures available. You can work on in terms of addressing the carbon footprint in the concrete mixture. There is a lightweight concrete, pervious concrete, high performance concrete, waterproof concrete, or self-compacting concrete. These are different varieties of concrete materials available. So the question is, are we using the right type of the concrete for the right applications? That is number one. The second question is, okay, to what extent we are able to add additives as part of this concrete? So friends, you all know the concrete making happens always next to the project. And in the concrete making process on site, when you do the site concrete mixing, typically there is some amount of additive. When I say additive, something like a fly ash or GGBS getting added to the concrete. For an example, typically it is added to the extent of about 15%, 10 to 15%, anywhere between, depending upon the concrete design. And to that extent, suppose if I'm adding about 15% of fly ash or GGBS, to that extent I am able to reduce my cement consumption in the concrete. That means to that extent I am able to reduce the cost. To that extent I am able to reduce the carbon footprint as well, because the fly ash and GGBS, they are waste material from industry. So you are able to reduce the carbon footprint. But the question is, and these materials, when you start increasing the addition, there are ready-mix concrete mixtures available wherein you can significantly increase this additive content. Depending upon the strength and depending upon the concrete design, anywhere between say 30 to 50%, you will be able to increase the additives. So if you are able to increase the additive to that extent, obviously you will be able to bring down, number one, the cement consumption. The second, you will also be able to reduce the carbon footprint of the building. So this reduces the overall carbon footprint, embodied carbon of the building as well. And second aspect is, see, for example, a lightweight concrete kind of mixture, it not only reduces the carbon footprint of the building, this also improves the thermal insulation property of the building. Say, for an example, this lightweight concrete has got a very low density. The lower density anywhere between say 800 kg meter cube to 1200 kg meter cube. And at this stage, the thermal conductivity of or the U value of this, if you look at, it is much better compared to a conventional concrete. So when the thermal insulation property is much better, obviously the heat gain in the building will come down. If the heat gain in the building comes down, you will also be able to reduce the air conditioning load and hence the energy consumption in the building. So this is a case study, a comparison of a conventional RCC wall as well as a lightweight concrete wall. A conventional RCC wall, if you look at, the U value is close to about say 2.5 watts per meter square Kelvin. Whereas if you look at the U value of a low density concrete, it is about a 1.6 watts per meter square degree Kelvin. So if you do all the calculations, you will be able to very clearly reduce the heat gain at least by about 4 to 5%. You can do your calculations. You'll be able to significantly reduce the heat gain. So obviously, since it has been part of the construction itself, this goes for lifelong, and the saving is for the lifetime of the building. May I request to mute mute their mic. The another aspect is, of course, there are high strength concrete materials available. These high strength concrete materials, of course, you need to use it depending upon the requirement. And the advantage here is, if you go for higher strength, obviously you will be able to bring down the quantity of the concrete. Not only the quantity of the concrete, you will also be able to bring down the steel consumption as part of the concrete. I am not saying, okay, you can use high strength concrete everywhere. You need to use the high strength concrete also judiciously, depending upon the requirement, and then take up the high strength concrete. If you are able to do the high strength, incorporate high strength concrete by design, we have the opportunity to bring down the steel consumption as well as the concrete consumption significantly. Then another major product category, we all need to look at is the steel as part of the construction. At the moment we talk about steel. Steel is a very high, energy intensive industry. The second thing, the carbon footprint of the steel material is also significantly high. But a lot of efforts have been taken up to bring down this carbon footprint of the steel now. See, there is an eco-labeling. We have GreenPro eco-labeling for the steel as well. It looks at various properties of the steel. Typically we look at in terms of only the strength of the steel, but we are also looking at in terms of how ductility has been maintained. This is a very, very important parameter as part of the steel utilization. Because from the durability point of view, more than the strength, the ductility matters a lot. So the ductility, which is a tensile strength to yield strength, we need to look at. We should be more than about 1.15 here. And also we are looking at in terms of corrosion resistance property, because this is one thing which reduces the life of the building. So the corrosion resistance also has been looked at. And in this process, we are also looking at in terms of how the resource efficiency has been improved in manufacturing process, so that the lower carbon footprint has been achieved from the steel making point of view. So these steels are identified and then eco-labeled. So friends, these are some of the materials I just thought of highlighting. Many a times we look for, okay, how we can establish the carbon footprint of the whole building. And these numbers, whatever you are seeing on the screen, these numbers are based on the actual data, whatever we have been receiving from the Indian manufacturing units. Many a times we have the tendency to use the international softwares. It could be any software for that matter. I don't want to take any specific name. They have their own inventory, life cycle inventory. And in that inventory, the numbers, whatever they are using, are the European numbers and American numbers. Our submission to you all is, you please make use of the actual carbon footprint of our Indian product manufacturers. Because, for an example, if you take cement, typically they use close to about, say, 850 to 900 kg per ton of cement, which is no more valid. Indian cement plants are much, much better. The carbon emission of the Indian cement is much, much lower, even compared to the European and American cement manufacturers. So my request to you all is, look at the Indian manufacturers' carbon footprint and use for estimating the carbon footprint of the building. So these are some of the points I just thought of sharing with you. How can you identify these products? These products can be identified through the GreenPro eco-labeling. This is an initiative launched by CII. We evaluate the products based on the holistic life cycle framework. When I say holistic life cycle framework, it addresses all aspects of the life cycle, and also it has been internationally recognized. The Global Ecolabelling Network has recognized this GreenPro eco-label. This label helps in achieving the sustainability goals as well. So what is the approach? We assess the product as holistically based on the life cycle approach. When I say life cycle approach, we not only look at the product performance, we look at from the raw material, the manufacturing process, the performance of the product during use, and also the end of life management. And then it has been evaluated by a third party, it has been tested by a third party, and then the GreenPro certification has been issued for this product. So these products are having the lower carbon footprint. So my request to you all is to make use of the GreenPro certified products for your construction. What are the benefits from the manufacturer's point of view? There are many. Easier to convince. There are export opportunities also because this label has been recognized in other countries as well. There is a lower resource consumption and hence the lower carbon footprint. Easily it differentiates the products from the competition, and obviously there is an increased market reach as well for the GreenPro Ecolabel products. You may be surprised to know, especially from the manufacturer's point of view, there are about 11 public works departments across the country. They have mentioned the GreenPro as a criteria in their tender document. So more and more organizations are, asking for GreenPro Ecolabel products. Number one, to ensure that yes, the required green features are met, and obviously they are all looking for a lower carbon product as well. And in terms of private organizations, there are many leading developers. I have just put only few names here. There are many leading developers who are asking for GreenPro Ecolabeled products. As on date, we have more than about 5,100 products certified by GreenPro, and they are available in the market from more than about 170 companies. Any product category from the construction industry point of view, if you look at all the leading players, all major leading players are there, and they have got their products certified. So friends, this is how I would like to conclude. Obviously from the low carbon building point of view, there are opportunities to reduce the embodied carbon as well as the operation carbon of the building. And when we start doing this, it makes business sense as well. Lower the carbon, obviously your operating performance also improves a lot, and it makes business sense. And it reduces the carbon emission of the country as a whole. It addresses the carbon emissions in the supply chain. So it creates a kind of win-win situation for all. Not only from the builder's point of view or the developer's point of view, even from the manufacturing industry point of view, the end user point of view, as well as the nation at large. So let us go for carbon neutral, work towards carbon neutral, and start using more and more low carbon products, low carbon lifestyle, etc. So with this, I would like to close here. Thank you very much for the opportunity. Over to you, Pratik.
Thank you so much, Karthikeyan sir. It was a really nice presentation. You have exactly, specifically for different products, you have highlighted how you can make low carbon products, make use of those low carbon products. So that is one great thing. Definitely all the participants would have received a lot of knowledge out of it. So we have this question answer session, but we have exceeded our time limits. So best we can do is I can ask one question from each speaker. So that way we'll be moving ahead. So first question is for architect Sheetal. So as we are moving towards net zero, previously people moved from conventional buildings to a green building. Then now people are moving towards a net zero building. So it's a two-parter question that how do you feel the people are ready for accepting or ready for the net zero building, taking in as making their new projects, and what would be the cost implications? Like how much additional cost would be there if you're making a building net zero? Sheetal ma'am, you're aware?
Just the rest.
Sheetal ma'am? I think she's not there. Yes, so I think the next question is for Kate. Kate, the question is, can eco-label be considered as one form of disclosure? If it is a type 1, type 2, or type 3 disclosure. That's the question we have received from your side.
Yes, absolutely. I do see it as a disclosure because if you can say and authenticate that you have procured an eco-labeled product, that is certified and with a very transparent standard. So the disclosure sits within the eco-labelling standard. And so as long as you can demonstrate that you have actually procured that eco-labeled product, and then certainly that level of verification through certification does provide that rigor of disclosure.
Thank you so much, Kate, for the quick answer. SK, next question is for you. Can GGBS be used as an alternate recycled material wherever fly ash is not available? And what will be the impact on U value with using GGBS?
Okay. GGBS can certainly be used as an alternate material. The property of these alternate materials is, it has got a better thermal insulation compared to pure cement. When you go for, you cannot use GGBS in case of making a brick. That is not possible. That has not been explored. Obviously, you need fly ash for making a brick. But when you want to go for concrete, instead of using the fly ash as an additive as part of the concrete, you can obviously use GGBS as part of the concrete. So when you start using the GGBS, yes, the cementitious material, the property is much better. It gains strength over a period of time. The beauty is it has got a much better U value compared to conventional concrete. So that improved insulation property obviously reduces the heat gain in the building. So it can be used. Yes.
Thank you so much, Karthikeyan sir. So I believe it was a fruitful session to each and every participant. But I think we have skipped our break as well, and we'll be starting with the next session directly.
Thank you, Pratik.
Thank you.
And thank you, Kate. A nice meeting with you on this.
Thanks so much for having me.
Thank you
so much, Kate, for joining us, and Karthikeyan sir for giving us this beautiful presentation. Thank you. So, just a second. Moving ahead to the session 2, the low carbon supply chains, product materials and technologies. So presently in the industry, all the manufacturers are concentrating about making their products green, but the aspect which they're considering right now is making their product like energy efficient, or most probably they're trying to reduce the impact on the environment afterwards. But nobody is taking care of the raw material which they're taking. So we have aligned 2 manufacturers and one gentleman from SEMA Pro, the LCA expert, I would say. So these people in this session would try to will be elaborating much more on the low carbon supply chain and how it is going to influence the low carbon, like the carbon emissions of products, materials and technologies. So without wasting time, let me introduce our first speaker, Devendra Pandey. He's the technical head at Ultratech Cement Limited. So he graduated from Motilal National Institute of Technology, MNIT, Allahabad, India in 1994 from Bachelor of Engineering Civil. He has been involved in the quality control and technical services function in the RMC industry in India from the pioneering years of 1995 with an overall concrete technology exposure of more than 25 years. Currently responsible for products and processes within RMC business of Ultratech Cement Limited, the market leader of Indian RMC and cement industry. This includes and involves development and pilot sale of new specialty concrete products, disruptive research for new concrete applications, technical training and development, quality management and certifications. Also, he has a rich international exposure through engagement with specialty products research and concrete manufacturers covering Europe, Asia, and other Middle East. through local know-how on use of advanced concrete materials like fly ash, microsilica, GGBS, ultrafines, fibers, and high-performance concrete-related ingredients. Also, he has been involved in leading capable teams of concrete technologists and technical managers, which have been responsible for commercial application of a large variety of value-added concrete products. So, Devendra sir, I would welcome you to this session. I'll stop sharing and you can sir, switch on your camera and you can start the presentation.
Yeah, thank you, Pratik. Thank you to CII and IGBC for organizing this event. Very rich content, and we have been, it's been very informative this afternoon. Let me share my screen and go ahead right with the presentation. I hope my screen is visible. Can you just confirm?
Yes, sir, it's visible. Perfect.
Okay, yeah, so thanks. And okay, so ladies and gentlemen, the topic which I'm going to cover is basically low carbon concrete solutions. And we call it amazing because we believe concrete is an amazing material with a lot of potential. Lot of performance tweaks can be done with this material, and hence it's an amazing material. But before I get to some of the emerging technologies in concrete itself, let's talk about ready-mix concrete, which in itself in our country we have been very slow. We have been late adopters as a country as a whole. We have been making our concrete at site a lot. So this slide basically represents the process of site-made concrete on top. The same parts of the process when you use ready-mix concrete, we use better technology, better equipment, more predictable systems, cleaner environment, so all of it. So even before we start trying to adopt to more modern technologies, we need to, as a country, I'm talking about industry as a whole, we need to be conscious about making ready-mix concrete as our choice rather than trying to make our concrete at site itself. A lot of benefits of doing that, right from reduction in labor, improvement in quality, improvement in speed, convenient process of purchase, reduction in wastage, reduction in pollution, more sustainable, lot of performance related varieties are possible. Gone are the days when we had this excuse that we don't have ready-mix concrete plant around us. So today's spread of ready-mix concrete in the country goes up to tier 2 cities, and in some cases even much smaller cities as well. So this is a broad level spread of ready-mix concrete through the country. So we have sufficient, and it's growing, and I'm glad to say that adaptation is happening fast. And now coming to the subject of what are those varieties on a broad level of concrete which qualify as green, which help us reduce carbon footprint, which help us reduce energy consumption. So these are some of the varieties. And of course, many of these products are already covered under GreenPro Ecolabel. So some of those are more emerging in nature, and I'm sure that in times to come, GreenPro is going to consider those materials as potential candidates for eco-labeling. So instead of going through this list, I will just jump into the products types directly. The first slide, basically, it was covered a little while back by Mr. Venkatagiri also. This is from the latest publication which GCCA has done, and it basically captures the the composition of OPC, which is ordinary Portland cement. PPC is Portland Pozzolana cement, which has fly ash, about 31% fly ash in that. Portland slag cement has about 57% GGBS in it. Composite cement, which has around 50% of fly ash and GGBS combined in it. Regarding the carbon footprint, so this is where OPC is at about 740 kgs of per metric ton, while PPC is at 507 and slag cement is at 312 and composite cement is at 351. So this is when you directly use the cement, making the choice of cement. But when you are designing a concrete mix, you have a little bit more liberty, or your ready mix supplier has a lot more liberty in tweaking with the mix and targeting a certain percentage reduction in the carbon footprint of the concrete itself. So I'm just showing you here 3 categories of concrete products which have 30%, 40%, and 50% reduction in CO2. How is this done? So here we go. I'm showing to you here 4 mixes. The mix one is basically if we made an M30 grade concrete using just OPC. So it would consume about 410 kgs of OPC, and the CO2 footprint per cubic meter of concrete only for material production. I mean, we can, of course, extend this analysis to right from up to construction and even in the life cycle. But at the moment, I'm covering the material. So concrete itself is 413 kg per meter cube of concrete, while in mix 2, what you see is an incorporation of fly ash within the allowable limits of the Indian standards. So the embodied CO2 reduces to 282, which is a 32% reduction. In mix 3, this is very similar to composite cement, which has 123 kgs GGBS, 82 kgs fly ash, and 205 kg cement. And what you see here is 231 kg CO2 per cubic meter, so which is a 44% reduction. And then lastly, in mix 4, what you see is about 60% reduction. So the point is that the information available to us today allows us to certify a concrete mix based on its carbon footprint. And the specifiers should, I think the time is coming when specifiers can start specifying, not just based on grade of concrete, but also based on CO2 footprint. And I think concrete suppliers would be able to support this kind of specification. Another interesting development in the field of concrete in order to reduce energy consumption and CO2 footprint is use of recycled aggregate. We also call them C&D aggregates, construction demolition. So basically what you see is on the left side of the slide, the demolition of old structures. The waste produced traditionally was being dumped into dump yards, and it was causing environmental crisis and hazard. Now there are mandates across most of the municipal corporations that this waste needs to be recycled in plants. Government is supporting that initiative, and in a lot of locations you now have these plants which are recycling this material in a very proper, in a very scientifically designed setup. And on the right, what you see is the recycled coarse aggregate and fine aggregate which has been produced, and our standards allow us for part usage of these materials, and a specifier can specify use of C&D aggregates or recycled concrete aggregates within their specification, and concrete suppliers are capable of producing concrete using this. Now, another approach towards improving the sustainability or reducing the footprint is basically making our materials last longer. So building durable structures is an important approach. Without getting into the too much of the technicalities of this subject, but the various kinds of problems which lead to the lower life of concrete structures can be carefully approached, and there are solutions available right from usage of supplementary cementitious materials to uses of fiber to improving the crack resistance of concrete, and also improving the workability of concrete to facilitate better compacted structure. All of this put together can lead to structures which can have a very predictable high life, to maybe to the extent of 100% increase in the life of the structure, and hence in the life cycle basis, lesser consumption of material. Now, another variety of concrete, what you see popularly known as self-compacting concrete. Self-compacting concrete, as the name suggests, it does not require the compaction effort required at site, and hence it reduces, of course, it reduces labor, it improves the speed, but compaction itself is a energy-driven process. It may be a small component, but it also causes noise pollution at sites, and all of this can be sorted by this variety of concrete, which is does not require any manual compaction at all. Of course, there are other benefits, like you can have absolutely gorgeous finishes on the surface of concrete. You can imprint, emboss, you can have exposed structures, etc. Another interesting variety of concrete is lightweight concrete, and it's basically a very good filler material. Sand is no more available in enough sufficient quantities. It also spreading sand as a filler in even under tile bedding, etc. in the construction site, it causes a lot of dust, pollution, etc. And a better alternative to that is a lightweight concrete, which apart from being smart, being very easy to use, it also has a tremendous benefit of thermal insulation. So it has a very high thermal insulation value. So using it in roofs, etc., can give us very energy efficient buildings. Added to that, the same material also has a benefit of fire resistance. It can stop the spread of fire between different floors of the building. So it's also used as a fire stopping material. This is some of the usage. Another variety of concrete is decorative landscaping material, and it again is the point about this is it increases the life of your landscapes, and increasing if we use materials like tiles and pavers in our landscape every 5 to 7 years, we need to revamp those, and that much material is getting wasted, and of course there is cost involved. There are hassles involved, while here is a concrete alternative to landscaping, which lasts as long as your building lasts, with a lot of beautiful varieties there, colors, patterns, etc. So, it can be a choice material for architects, but it is also a very green material in terms of the life. Another variety of concrete here, what you see is pervious concrete. Pervious concrete, as its name suggests, it is porous concrete. It allows water to seep through it. So it's again a very good landscaping material because it conserves water. It recharges the groundwater. Hence, it can be a very sustainable alternative. Going to this is an upcoming material, very, very short, just a mention of it. It's a glow in the dark concrete, can be a very nice material for places like jogging tracks, walkways, again a landscaping material, but as the name suggests, it will absorb the sunlight during the day and it will emit the light in the night, and of course it will reduce the cost of lighting, etc. in the landscape. One more emerging material is ultra high performance concrete. This concrete has a very high strength in the tune of 130 to 150 MPa, even higher, and it has a very high flexural strength. And what is the benefit of this material? For it allows thin section members. So facades, etc., can be made of 1 inch thickness. 4 meter tall facade can be just a 1 inch thick member, because by virtue of its own very high tensile strength, it does not require primary steel, so no requirement of cover. Because of no requirement of cover, you can still build 1 inch thick and don't worry. So very promising material, amazing potential. On its own, it looks like very highly cementitious material, but by virtue of reduction in overall material quantum, it's the overall footprint of your construction is going to be lower when you use a material like ultra high performance concrete. So that's it for now. I hope it added value to this session. Thank you.
Sir, thank you so much for such a lovely presentation, sir. It was a very wholesome presentation. Plus, I believe a lot of people would have understood about a lot of different types of concretes and their applications. Previously, they just used to believe on a conventional material for a specific product, but I believe concrete can enter a lot of new areas now. So thank you so much. We'll be taking the questions in the end. Thank you so much for the presentation.
Thank
you. We have this unfortunate news that due to some emergency, our second speaker, Rohit Lamba, couldn't be present in this session. Just a second. So Rohit Lamba would not be able to present in this session, whereas we'll be directly moving to Sunil sir, Sunil Kumar. He is the director at SEMAPro India Limited. Now, Sunil Kumar is head of SIPL Private Limited, a niche consultancy firm in LC, GHG and sustainability domain. Mr. Kumar, an alumnus of IIT Delhi, has done extensive research on collecting India-specific life cycle data sets for major background processes like electricity, transportation, oil and gas, cement, steel, plastic, etc. The data collection for other industrial verticals like biofuels based on sugarcane, jatropha, biochemicals, and bioplastics based on molasses, guar, gum, organic cotton, corn, plywood, and many more has also been completed by him. Work on other industrial verticals also going on under his leadership. The above data sets will be enable Indian organization to calculate environmental burdens very accurately. So Mr. Kumar is a visiting faculty at various IITs, Kuwait University, MASDAR University, and many more technical institutions, and has trained over 500 professionals and students in various basic and advanced level courses on LCA. So Sunil sir, I would like to welcome you to this platform to share your experience that how life cycle analysis can help understanding the low carbon supply chains.
Thank you, Pratik. And I am actually on tour, so my internet connectivity will be slightly, you can say, in a compromising position. But I will try my best to complete the presentation in time. Okay. And if you allow me, I will not share my photo so that bandwidth.
No problem in that, sir.
Okay.
Do you want me to share my screen with your presentation, or will you be able to do that?
Yes, that will be better if you can do that.
All right, I'll share it. Just give me a minute.
Or you can allow me, then I will let you share
Sir,
it.
I'm just opening. Give me a second. The screen is visible, right?
Yes, yes.
So just tell me next, I'll change the screen that way, right?
Okay. So thanks for inviting me to this wonderful group of experts. And basically, we are into life cycle assessment calculations and all for every type of products. And here we will focus more on how to calculate low carbon. If you are saying that it is low carbon, then how? And how actually it is calculated. So basically, it will be slightly on the say consultancy type of things, and you should know if your supplier is saying that our product is low carbon, and how to verify that yourself without going for any say third party verifier also. In the last presentation by Mr. Pandey, it was a wonderful presentation. He showed 3 types of products: mix 1, mix 2, and mix 3. And he said that more than 40% reduction in carbon footprint was achieved in mix 3. So with the help of this tool or any other LCA tools, you will be in a position to find out why mix 3 is having low carbon. And that will be a very handy tool for you and very handy knowledge for you. Okay, so in this next. So contents of this presentation would be how can LCA be applied to achieve low carbon supply chains, the importance of data accuracy, and brief introduction to GreenPro software just for the sake of calculation part. Next, please. Just short description of the services offered by our company, that we provide carbon and water footprinting, full life cycle assessment studies, screening LCA, life cycle costing, and circularity index calculation based on Ellen MacArthur Foundation's guideline, and complete sustainability studies that consist of life cycle assessment, life cycle costing, and life cycle social assessment. Then environmental product declarations and social life cycle assessment as a separate study. So all these things we can definitely provide to each and every organization or each and every product. Next, please. So what are different phases in a product's life cycle? So briefly, you can see product life cycle here. We start at extraction of raw materials, then it goes to manufacturing and production, packaging and distribution, purchasing, use and maintenance, and disposal. In this in this presentation, we will be focusing on cement. So extraction of raw material in case of cement starts at extraction of raw materials and limestone. That limestone is converted into clinker. Then clinker is mixed with say fly ash, gypsum, and many other materials depending upon the strength required by the cement. Then it is packaged and distributed, purchased by people, and then it is used. And finally, it goes for disposal. And then again, whether you can use the waste product in, say, as explained by Mr. Pandey, that this can be successfully used for some or other applications. So this is we will be explaining in quite detail. Next, please. This is a LCA process flow of a product, what I explained in the previous slides. So as you can see, the raw material manufacturing phase. At each phase, you have raw materials, electricity, emissions, transportation involved. These are the things that contribute to carbon footprinting. That is how much carbon you are emitting to the environment. And the basic idea behind having the low carbon structure is that you should know from which part of your supply chain you are getting your carbon footprint. And this is extremely important. Otherwise, you will not be in a position to make your system more efficient. Like in the case of cement, clinkerization is the most energy intensive process. And if you want to reduce carbon footprint of your cement, then something must be done to reduce the clinkerization process. So one method could be reduction of dependence on clinker and replacement of clinker with the fly ash and other say slag, etc., which are very little in comparison to clinkers in terms of carbon footprint. So these are the methods that you have to find out. But the basic idea is that you must be aware from where you are getting your carbon footprint. So in the manufacturing process in the cement plant, the powdering process, like we have clinker, gypsum, fly ash, etc. These are powdered to make your cement. This is the process that is contributing a lot. Another thing that can help you to reduce carbon footprint of your product would be changing the type of electricity you use. There are many companies, Diamond Cement, for whom we had consulted some times back. They have created, say, solar power stations in their plants that can definitely reduce total carbon footprint of your product. Then comes the use phase and waste management part, and whether you are having the recycling, that is part of the waste management. If recycling is happening, then you are conserving the virgin materials. Aggregate is definitely in short supply, and if you are using waste material, demolished material, and using that as in place of aggregate, then that is also going to save you a lot of carbon footprints. So these are the areas which I have found out through life cycle analysis, which you can also find. Next, please. So this is a simple blocks of slag cement production process. You have site data and you have background data. Background data is how clinker is produced, how slag is produced, how gypsum is produced and transported, how electricity is produced and distributed, and how diesel is produced and transported. If the cement company is an integrated cement plant, then the chances of background data having accurate background data collection is very good, and in that case your accuracy part will be good. But in some of the cases where clinker, slag, gypsum are getting outsourced, then you need to have a very good idea how these are produced and how these are getting transported. Transportation is again a very, very important factor in carbon footprint analysis. Then come to the plant side, which is the site data. So you have clinker, slag, gypsum, electricity, transports, etc. And these are converted into cement. So total greenhouse gas or carbon footprint analysis of cement depends on site data as well as background data. And from my experience, I can say that more than 65% of carbon footprint is attributed to background processes. So from where you are getting your raw materials are very important, especially in case of cement or RMC also. Next, please. Now, what are the things that are influencers to accuracy of life cycle assessment or GHG results? So if you have created a process that has been cement production process that has been modeled on site data, or have you created the process for electricity production for your site, or you are simply getting data from Mr. Karthikeyan said that most of the LCA softwares have data from Europe and US. So are you using data available in the software to use electricity process? Or similarly for diesel and gas production, are you using US and European data? Or similarly, have you clearly produced or modeled a clinker or slag or gypsum production process? If answer to any of these is no, then you have compromised your accuracy. And if you are using European and US processes available in the software used to model LCA, then again you are compromising your accuracy part. Next, please. So accuracy robustness of GHG-LCA study compromised, or in other words, greenwashing has been done. How? So some analysis we have done. Next, please. GHG impact of 1 kWh of electricity, Indian data versus European data, US data. We have collected Indian data for electricity from coal, hydropower, and solar power, etc. Electricity from natural gas also. And this we compared with the eco-invent data. Eco-invent, you must be aware, is a very relevant source of information as far as LCA data is concerned. Then data from US was taken from RER is average of Europe, and that was compared with Indian data for high voltage electricity that we have collected from NTPC. And when we compared it, we found out that the difference in carbon footprint was up to 50%. So if you are, instead of Indian data, you are using data from US and Europe, then you are certainly compromising the accuracy part. So if you are not able to accurately calculate the carbon, then the whole process of nearing low carbon thing would go to waste. Next, please. Similarly, in case of transportation is involved. A lot of diesel is required in transportation part, in cement factory especially. Everything is done through trucks. So we can compare diesel produced at Indian Oil Panipat, and that was compared with equivalent data available for rest of world and Switzerland, which is Europe. Here also the difference was about 20%. So consider, next please. Considering electricity and considering say transportation, you have seen that how much accuracy you have compromised. So if you are calculating your low carbon based on European data, then I'm sorry to say you are not doing justice to your low carbon efforts. You must do this on your site specific data. Now, you may ask the question, why does this happen actually? So electricity production mix is different. What does it mean? In India, electricity, as per CEA data, around 65% of electricity comes from thermal power. Basically, coal-based power plant and natural gas power plant. In so western part of India, this goes up to 70-75%. In southern India, it goes up to 70%. Then electricity mix contribution, coal contribution in electricity mix in Europe is hardly 35%. Similar is the case with America. So that is the reason per kg carbon footprint is very low in case if you are using data from Europe or America. Similarly, transportation distance and means are different. Just because of say L1 case, if you are getting your cement from a very far off place, say 1500 kilometers or so, then again you are contributing a lot on your carbon footprint. Input materials are different. Also, production processes have technological differences. So production process like cement capacity of cement plant in India, capacity of power plant in India are smaller compared to the big power plants and cement plants and refineries in Europe and US. These economy of scale also contribute to some percentage of lower carbon footprint analysis. Next, please. Now, how we actually do this in Singapore software, I will quickly go through this. So we create a flow chart. In the flow chart, the major processes are limestone, extraction of limestone, then it goes to clinker production, and then finally OPC, that is ordinary Portland cement production. Three major processes are there. Next, please. Then we create a methodology. Based on the methodology, we calculate carbon footprint analysis as well as many other impact categories. Similarly, we selected because it also has for carbon footprint analysis, it uses IPCC 2021 method, which is the latest one in terms of carbon footprint analysis. Next, please. This is how you get graphs for your HA results. This result is for 1 kg of OPC, that is ordinary Portland cement, and green shows clinker production. So as you can see in almost all the categories, including carbon footprinting, clinker constitutes the lion's share of total environmental impacts. In case of clinker, you can say global warming. Global warming, the third from left, is about 75% of environmental load is coming from clinkerization. Next, please. This is how you get the hotspot analysis. For each and every impact category, you will come to know from where your impacts are coming. So for global warming, as you can say, clinker constitutes 74.7, gypsum very less, transportation very less, electricity constitutes 24.2. So the major area of improvement in case you want to go for low carbon or lower carbon, it is clinker production. So either you can switch, replace clinker with some other material, considering strength and other parameters, or you can switch over to renewable sources of electricity. Next, please. These are the data sets we have collected from various reputed companies in India. So we have transportation details from ARAI Pune, then production of diesel, petrol, etc. from 3 refineries in India, IOCL refineries. For electricity from coal, we have collected coal production data from Coal India Limited and NTPC for production of electricity. Similarly, many other parts we have covered for Indian data set so that we have very accurate calculation. Next, please. You also get sector-specific data sets. Here, example we have given for cement, but you can get sector-specific data sets for almost all industrial vertical available under the sun. Next, please. And SIPL Private Limited or GreenPro, these are the companies where we provide our services or software. ABB, OCL, BPCL, John Deere, universities, almost all the IITs, IIT Mumbai, Chennai, Delhi, Roorkee, Kharagpur, everyone uses GreenPro for research purposes. And research institutions like CSIR and ICR institutions, CRRI, CBRI, Central Building Research Institute, they all use GreenPro. Individual sustainability partners and small and medium organizations, they all use GreenPro. Next, please. So how will we support sustainability? We can do life cycle assessment. You can do hotspot analysis to find out the areas which are gray areas in terms of carbon analysis. Then you can find suitable materials. You can compare two materials, which one is better. Find more suitable materials in terms of plastics, rubber, paints. Similarly, you can emphasize on site-specific data to calculate most accurate environmental results, and comparative assessment will support you in establishing you as a sustainable manufacturer. Next, please. So thank you. That's all for this wonderful group, and your questions are welcome.
Am I audible now?
Yes, you are audible.
Perfect, perfect, perfect. So thank you so much, Sunil sir. It was a very comprehensive presentation. And as part of a GreenPro certification team, I totally get that LC is a study which is required in the future for making low carbon buildings, low carbon products, or you could say actually a detailed analysis towards the supply chain. LCA is a great tool which can be utilized by everyone. So I think we can go ahead with the questions. Sir, first question is for you. Just a second. So presently, Devendra sir, first question is for you. Sir, we understand that cement and concrete industry is being doing a lot of work in reducing scope 1 and scope 2 emissions. So we want to understand more about the initiatives Ultratech is taking in order to improve the scope 3 emissions. Because now the concrete is being sent to all tier 2, tier 1 cities as well, tier 3 cities as well. So just wanted to what kind of measures Ultratech is taking to reduce scope 3 emissions as the transportation emissions?
Yeah, so there are a lot of initiatives under pilot in terms of transportation. Actually is an important part of RMC because we are transporting concrete on a very regular basis. It's an integral part of the ready-mix concrete business. So there are a lot of initiatives in terms of alternative fuel and also reduction in but naturally the technology also reduces a lot of dust pollution in the city when you adopt to ready-mix concrete. And that's something which actually needs to be spoken about a lot more, because sometimes there are challenges in the urban environment in cities, etc., in terms of licensing of the RMC plant. It's very interesting that a lot of times in a city we allow a lot of aggregate and sand trucks to move around in the city and then cause a lot of dust pollution. And instead, there is a need to kind of give a lot of support to RMC industry to set up more plants in the cities. Because if you have transit mixers carrying concrete a lot more, then it is a covered, it's a totally covered thing. It's a wet material. It doesn't cause dust, etc. So, every year in our Delhi NCR and all, we face the problem with the pollution and visibility issues that will get solved in a major way. Apart from that, in the transportation itself, use of our vehicles, we are taking a lot of pilots in terms of use of alternative fuels and efficiency of the vehicles, etc. But most of these are in the pilot stage at the moment.
Still, I feel a lot of things are being done now. So definitely we'll be seeing much more improved carbon emission reduction when scope 3 emissions are concerned.
Right.
Okay. So next question is for Sunil sir. Sir, I think as we understand, LCA's data specific to India is yes, you're researching a lot and a lot of areas have already been done and completed. Now, what I would like to ask is, what would be the next step? As a lot of technical experts must be attending this session, we wanted to understand what we should do in order to collect this data, or we can help India to improve this data specifically. What should be the next step by SEMAPro to standardize how we can get this LCA data or GHG data, so that more accurate studies can be performed for all the sectors of India?
Okay, for this region, what we are doing, we are sponsoring almost all technical universities, including IITs, and we are giving 60% discount on the software price, so that more and more people come to the research part. Second is that we are organizing training programs, especially for students and PhD students. We sponsor about 25 PhD students everywhere. We supply them CMAS Pro software without any charge, and we also train them. So these are the initiatives we are taking. Along with Ministry of Environment and Forest, we are planning to start our own life cycle impact assessment methodology. All the methodology like IPCC and all, these are not for Indian region. And there is one of the largest, you can say, contributor to greenhouse gases, but we do not have our own LCIA. So the next step is definitely to have our own LCIA.
Perfect. Actually, we would be love to be a part of this as well. So anytime, let's connect over some call afterwards, and let's try to collaborate, because we must be having a data of LCA.
Certainly.
Sure. So I think we can conclude our session here. I would like to thank Devendra sir and Sunil sir for these lovely presentations. Sir, so any questions, if we receive on chat box, we'll be mailing to all the speakers if any question was left. So that is one thing. Other than that, thank you so much for joining us, to all the participants. And we would be, the Green Building Congress is being organized in October. So we would suggest everyone to just give a look and try to be present there, so that more and more green building initiatives or green product initiatives can be observed from there. So thank you so much for joining us, Devendra sir, Sunil sir, and all the other speakers and our chief guests. Thank you so much.
Thanks.
Thank you. Thank you, Pradeep. Thank you.
Thank you.